In this video, I'd like to talk about the math question of the day for Friday, May 19th, 2023. And with this problem, we need to find the domain of this function f of x. We have the square root of x minus 2 divided by x minus 4. And a question like this might be taught in an Algebra 1 class, maybe in Algebra 2, but you are most likely to see this in a PreCalculus class. So at this point, go ahead and pause the video, try to work through this on your own, and when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through it. And domain can be a little bit tricky, but there are essentially two different concerns with domain. One is division by 0, and the other is square roots of negative numbers. But before we get into the specifics, let's just remind ourselves what the definition of domain actually is. And there are several ways to look at this. The simple way to look at this is you can ask the question, which x values can actually be graphed or can be graphed on the xy plane? Now, the more complicated way to look at this, or the more general way to look at this, is that domain is the set of all values of the independent variable that can be evaluated in our function. So which values of x can actually be plugged into the function where you actually get an output. So, like I mentioned, there are two main concerns with domain. And let's start with a function, let's call it g of x, which is just 1 over x. One of the main concerns is that we cannot divide by 0. So for this particular function, the domain would just be that x can be anything but 0. You cannot plug in 0 here, since then we are dividing by 0. And the other concern with domain would be square roots. Let's say we have a function h of x, which is the square root of x. Now this is a little bit more complicated. In high school, you learn that x has to be a positive number. It has to be greater than or equal to 0, since if we plug in, let's say -1, we get the square root of -1, which is the imaginary unit. This is equal to I. And we start dealing with complex numbers, which cannot be graphed on our normal xy plane. There are no complex numbers here. These are all just real numbers. So with high school math, this function h of x, you'll notice, looks something like this. If we actually graphed it, it has nothing on the left half of the coordinate plane. When x values are negative, we just don't have a graph there. However, if we extend our domain to allow complex numbers, there are ways to graph this with imaginary outputs. However, that's typically too advanced for high school. So in high school, you are generally taught that when dealing with square roots, the x value has to be 0 or bigger. It has to be a positive number. You cannot take square roots of negative numbers and actually graph those on the xy plane. So we will answer that question assuming a high school approach, but like I mentioned, there are ways to actually graph complex numbers. They're just more complicated. So looking at our actual function, let's start with division by 0. And by the way, you can never divide by 0, even if we extend our domain to complex numbers. Division by 0 is just not defined. It's never defined. And this might be straightforward to see that x can't be 4, since if you plug in 4 here, you get 4 minus 4, which is 0, and we would be dividing by 0. But for more complicated expressions in the denominator, we can just take our entire denominator and say that it cannot equal 0, and then solve for x. So we add 4 to each side, and x cannot be equal to 4. This is always excluded from the domain here, since we'll end up with division by 0. Now, from here, we can look at our square root. We can say that this expression in our square root has to be positive, or it could equal 0. But basically, whatever is underneath the square root, we can just say that that expression has to be bigger than or equal to 0. It has to be positive or 0 at a minimum. And from here, we can just solve for x. We add 2 to the other side, and we see that x has to be bigger than or equal to 2. So this is the other condition of our domain. And to summarize, we essentially combine these together. X has to be bigger than or equal to 2. Otherwise, we end up with imaginary solutions here. And again, we're assuming that this is more of a high school question. So we're asking which x values can be graphed on the xy plane. And if x is less than 2, then we can no longer graph those because we have imaginary outputs. So for our domain, x has to be bigger than or equal to 2, but it can also not be equal to 4 since we end up with division by 0. And we could just write it like this with these two statements here, or we can use set notation or inequality notation, or I should say interval notation. So let's start with our interval notation. We just want to combine these facts, and we're starting at our lowest possible value. We'll say that x can be as low as 2, and we'll use a bracket indicating that it can also equal 2. It's fine if we get the square root of 0 since 0 times 0 is equal to 0. So that has an output of 0. And then we'll go to the next highest value before we have an issue, which is 4. And we won't include 4 since when x is actually equal to 4, we get division by 0. So in that case, we'll use parentheses indicating that 4 is not included. Then we use a union, basically a fancy way of saying and in mathematical notation. And we again start at the lowest possible value, which is the other side of 4. And starting at 4, but not including 4, we can go all the way to infinity. And infinity is never included. We always use parentheses for positive or negative infinity. So this right here is our domain using interval notation. But like I mentioned, we can also use inequality notation. We can say that x is bigger than or equal to 2, but it has to be less than 4. And then we can say and x can be bigger than 4, but not including 4 for either of these. And it then just has to be less than positive infinity. So either way you want to write this using the interval notation or the inequality notation, or just writing these two statements, these all effectively mean the same thing, and these are all the domain of this function f of x.